In this video, we are going to discuss the properties of gas. At the end of this lesson, students should be able to describe the physical properties of gas. And then, students need to describe the variables that describe gases includes pressure, volume, temperature, and amount of gas. Matter can exist as gases, liquids, or solids. The volume of a gas is greatly influenced by changes in temperature and pressure. But the changes in the volume of a gas do not depend on the chemical composition of the gas. Due to this, gas laws such as Boyle's law, Chaucer's law, and Dalton's law of partial pressure can be used to explain the physical properties of all gases. Now, let's take a look at the properties of the gas. The density of gas is much less than the density of liquid and solid. It is noticeable only if we have a large collection of gas in a container. Gases do not have a definite shape. They take the shape of their containers and distribute themselves within a container. The random movement of gas molecules allows them to expand or contract. A gas volume refers to the space of the container in which its molecules have range to move. Thus, a gas does not have a definite volume. Gases can be compressed by decreasing the distance between the particles and the volume occupied by the gas. They are also expandable. Due to the large amounts of space between gas molecules, two or more gases can diffuse quickly and easily with one another to form a homogeneous mixture. Gas particles easily flow to pass one another. There are four variables used to describe gases. There are pressure, volume, temperature, and amount of gas. Now, let's discuss how the change of pressure describes a gas. Molecules of a gas are in constant motion, frequently colliding with one another and with the walls of the container. In their collision, the gas molecules exert a force on the wall of the container. Thus, more molecules means more collision. Therefore, more pressure will exert. Gases naturally move from areas of higher pressure to a lower pressure because there is empty space to move into. For example, such as a spray can. The standard unit of pressure is atmosphere or ATM. Other units include all the following given. The device used to measure the pressure of gas is called a barometer. The conversion unit of pressure can be converted from ATM into Pascal, Newton meter square, millimercury, and torr. Now, let's discuss how the change of volume can describe a gas. In a smaller container, the gas molecules have less area to move. Therefore, the particles hit the walls of the container more often. As volume decreases, thus the pressure increases. The volume and the pressure are inversely related to each other. The standard unit of volume is liter. There are 1 liter equivalent to 1000 milliliter. Other conversion unit of volume can be converted into meter cubic, decimeter cubic, and centimeter cubic. Now, let's discuss how the change of temperature can describe a gas. Temperature is a measurement of the amount of kinetic energy of the gas molecules. At a constant volume, raising the temperature of a gas will increase the pressure of the gas. This means that the temperature and pressure is directly related. Thus, the molecule will hit the wall of the container harder and more frequently. When the gas is heated, the molecules gain more energy and move faster and further apart. This causes the volume to increase. But at a lower temperature, the molecules have moved slower and have less energy. They are closer together, causing the volume to decrease. The standard unit of temperature is Kelvin. There are 0 degrees Celsius that equivalent to 273.15 Kelvin. It is known as absolute temperature. Other units of temperature include degree Celsius and degree Fahrenheit. Now, let's discuss how the change of amount of gas can describe a gas. When we inflate a balloon, we are adding gas molecules. Increasing the number of gas particles will increase the number of collisions. Thus, the pressure must be increased. The standard unit for the amount of gas molecules is mole. In a gas, the particles are in random motion and interact only through elastic collision.